Howdy. That's a continuation of the previous video, or the last video I made. It's about weather in general. Let's see if we drift off into something else, but that's the idea. So I have been talking about this in the last video, and I think I mentioned that all the weather systems, they are connected with each other. Always a high pressure system is connected to a low pressure system because it forms the circuitry. In other words, we have this kind of, I tried to explain this last time, the pillars on which we have the vortex spinning around, which are the ionic winds. And in my last video, I forgot to tell and show you so many things, so I try to remember now a few what I wanted to show you last time already, but I forgot. So now let me show you first what are the energy pillars and what are the ionic winds in weather, as I tried to explain last time, and now I will show you once again. It's not me actually, because it's Mr. Too Tough 2, Magnetohydrodynamics, the electric Coriolis effect. And how here you can see he's putting a plate there. Now let's just have a listen, hopefully you understand. Let's put the, is there any titles? Because it's maybe a bit hard to understand.
Visual effect that we're looking for. And need a little bit of black pepper to sprinkle on there, or sawdust, or anything that'll float. Some pieces will float, some will sink. You can see that the dynamics of fluid motion is what we're looking for. Probably have to let this settle down a little bit. Put some pepper on there so you can see how the water's moving, actually from top and bottom. I'll go ahead and zoom this down so that y'all see what we're doing here. Now in this setup we have positive electrode on the left and negative on the right, and current will be flowing from positive to negative. However, the electrons will be flowing from negative to positive, the opposite direction, which is, essentially the particle. And we'll observe that too in the experiment. We'll set these electrodes over into the solution. And again, this is under a north pole or a north magnetic influence. And we'll turn the switch on over here, and you'll immediately notice a rotation around both of them. You have a counterclockwise around the negative electrode and a clockwise motion around the positive electrode. Now, if you can look into the right and left-hand rules of electricity online and get into that, but you'll see that we would associate the counterclockwise motion with a low-pressure system, and we'll associate the clockwise rotation with a high-pressure system. And a lot of people will say, well, how do you explain the Coriolis effect, on the other side of the planet, that, these things tend to turn the opposite direction. How can electricity explain that? We'll zoom out a little bit so you can see that we're not changing the polarity whatsoever. I'm just going to simply sit this out of the way. In fact, not even going to turn it off. We'll sit this water down and simply turn the magnet over so that there's a south influence now the water's under a south influence. We haven't changed any of the charge at all. In fact, we haven't even turned it off. We'll set this back in here, and almost immediately we'll notice that the rotations have swapped. The right-hand side now is rotating clockwise, and the left positive side is rotating counterclockwise.
So this is, I think, very simple proof and evidence of what I tried to explain last time with the pillars of energy and the ionic winds. It is the very exact same principle that is going on in the weather, as we can see here. And maybe we could imagine that these pliers, or how you want to put it, because there is a height difference between the level of the water here. These are the pillars which are going up, and that's maybe the ionosphere, and that's the surface of Earth. And it actually doesn't really matter too much if there's water or not, because it depends on what is going on beneath the surface of the Earth, on which water is just the conductor of everything. So, and that's the time lapse I showed you last time. Where I found that plasma connection, and at the end of the video also this black cloud emerging out of nowhere. I think we have to go somewhere here. Yeah, here it is. Now let's check it out once again. Let me pause for a second. First, it seems that the action is going on here because we can see like these kind of tendrils or streamers or reachers, or however you want to call them. You can see them here already, the dark filaments here. And these clouds, they are rather round shaped, so they are in a way the opposite. And I don't know if the color of the clouds actually matters. Somehow the last thing I saw with this dark cloud emerging there was very, very interesting. But anyway, now we can see how this is approaching that. And here we have energy rising up. And all of a sudden, here in the middle, there is a cloud emerging. Somewhere. And you can see also here on the right side, there's a lot of movement going on. And it flows in both directions all the time. It's coming forwards, but it's also retreating at the same time. Now we can see the cloud here. That's a pity that we have this stuff in the middle. There's already, now I just noticed there's a dark cloud here already. As we go on, there's a second one emerging here. Okay. And out of that first white cloud, we have a darker cloud that is shooting in that way. Yeah, it sounds very strange. Well, but look at it. There's a white cloud emerging out of nowhere, and then we have a dark cloud emerging out of the white cloud. Yeah, what to do? A black sheep in a white sheep. But if we zoom out a little bit further, then we can see there's also action going on here. Here you can see this kind of plasma tube forming, as the rest of it makes a connection. That's about approximately the way of the connection that whole thing is forming here. And it's just only for a brief moment. There we have a very nice connection, and then the whole thing dissipates in a way. It loses its form. Now let's go back once again. And we can just watch that area. There is some vorticity going on up there. There is something upwelling. So we have some kind of a system, let's say here, and there's a bigger one here. And it may be that they make the connection and some whatever charge differential or electromagnetic potential of the Earth and atmosphere gets back into somewhat of an equilibrium. Now we can see the form. It makes the connection, and then up here we get more action. There's the tube. And there's more energy from the left coming in the clouds. These are bundles of energy. Now we can see the tube very well. Let me pause here for a second. That's the tube. I don't know. It's not possible to draw there. Yeah, there would be many other things to watch here in that picture and to talk about. But anyway, now we had the connection established. And in a way, it seems that the structure is dissipating to some degree. See, there's not that much of a cloud left anymore. It made the connection, it got discharged, maybe this cloud has something to do with that because it's having a rotational nature to it. Let's go back, I want to show you. Yeah, it's connecting also to somewhere. Let's have a quick look at that. See, it's just making the connection. It's coming out of nowhere, in a way. And I claim that we can see this kind of structure here, which would mean it would rotate. A bit hard to draw, but anyway. Yeah. Let's check this out. It's going to dissipate this here on the right side. Here's the connection made. Watch here. Connection, plasma tube. And the whole thing is just dissipating. It in a way discharged. Might sound strange, but this is how it seemed to me. So, and if you think about that, yeah, that's just in one cloud or one little thing, you know, it doesn't matter on bigger scale. Let me show you something. I have been watching this other storm in the Caribbean, Beryl or whatever it was or is. Let me show you a few things I noticed on Windy recently. Now, first of all, it's not Beryl, it's Debby, obviously. But anyway, we are looking at the 31st of July, where Debby is still very small or not even recognizable as something. But here there's something pushing very hard southwards, and it seems to have immediate influence in a way on the weather system of Debby. There seems to be some kind of a, it's pushing here and the energy goes that way, and a small connection is established to this storm, and this grows very rapidly in size. And I think Here we can see something of a connection. That thing. And maybe this is pumping up the whole system for a brief moment. Yeah, so Windy did have some problems with loading. And I also find it interesting that we have this kind of empty space here with the shape of a triangle. But there's also an area where we have basically nothing. It seems, at least on this screen, that there would be this kind of empty void, which could be some kind of a double layer. But on the edge of the double layer, we will see the connection established. And maybe it's just coincidence, maybe not, I don't think so, that Debby gets juiced up in the moment it gets established the connection to this one. Now let's go on one day further. Let's see if Windy can keep up with the loading. Yeah, there was an other some kind of an outburst, downburst, or whatever burst this kind of thing was. I don't know. From the same place, basically, as, yeah, it's from here, this front here, and it seems very big, and you would expect that it's very massive and stuff, but look at it, it just somehow ramps up and then it dissipates. Flop. There's nothing left. Within a few hours, the whole thing dissipates into basically nothing, except that the cloud band boundary is continuing. It looks rather strange or interesting. And at the same time, at the end, there's something going on here. That goes on the other side, or the other direction, which could be seen as some kind of a polarity switch or something. So what's there where we have that thing emerging? Salem. Kinmundi. And we have a water body. Yeah, anyway. Yeah, you seem to have very interesting geology in your place. I think that's a karst region, I guess. And if it's a karst region, we might have to expect these kind of things, because they are in a way discharging every now and then. So now let's go on with our storm. Debby it was, yes. And then as we go on in time, that is continuing its journey towards Europe or Iceland or wherever it's going. So Debby lost his main connection, or it seems at least that something that was amping it up And now there's something coming from this way, which seems to again amplify the Debby storm. And there are some plate boundaries, I guess they call them, but there might be also some very strong telluric current networks beneath the ground. Rivers and stuff like that are good indicators for places where you could expect telluric currents to flow. Besides many other things, more conductive things, such as metal occurrences and stuff like that. But my main point is, in a way, since it seems that Debby doesn't really have at the moment a strong companion to connect to, it doesn't really form as a very spinning feature because it would need more energy to draw in from somewhere in order to get higher structure, because it needs energy in order to get something structured higher. And we have to wait and see how this is going to play out. Now we are at the moment, that's 12 hours ago, and at the end of this time lapse will be the moment we have right now. And as I said many times, to me it seems more and more and more that weather is basically steered from below. So there is something going on beneath our feet. If we can observe such big happenings in the skies. And for those who are outdooring and stuff like that, like if there's a thunderstorm, don't go under the trees, because the tree always hits the highest place in the vicinity because it attracts the lightning. Right? So can you explain to me the lightning overseas, because there is no tree there? In other words, the lightning is attracted to something else. Because it's out on the sea, And for all those people who don't know, there are like thousands and thousands of volcanoes in the sea out there, somewhere down there. And if we go to just very quickly over to Google Earth and try to see what's there on the seafloor, there's not that much visible. Except maybe some ancient construction sites and stuff like that. But otherwise, they won't show you what's there. For whatever reasons. There's a lot of stuff down there. And also many things that naturally would attract lightning, such as submerged hydrothermal vents and stuff like that, where we have water flowing out of the ground, like in the sea out there somewhere. It doesn't need to be hot. Water is enough, whatever kind of water. And there's also a lot of sulfur in the sea water, which is also very interesting. And I guess if we would find, or there would be a possibility to find some geological maps from, let's say, this region here. I always drop my phone. Where are we? All right. From this region here, I think we could find something that could in a way explain of how these weather systems are moving. But I think I leave it here. I just wanted to show you some scalability possibilities about plasma tubes in weather and stuff like that. And yeah, and in the meanwhile, when I took some of those time-lapse pictures, I was searching for some pebbles. And maybe you have seen this one already, it doesn't matter, but that's sulfur. I guess they call this elemental sulfur, and it is within this quartz pebble. And I burned it with my little torch. It turned red and it really smells of sulfur. These are two of those I managed to cut open and polish a bit. Yeah, there are interesting stones. And it doesn't really, they don't stay wet at all. So they look much cooler in nature. Here you can see the difference. Like there is a drop of water, how much more color you can see. Because they need to be polished so much more in order to get them really shiny and stuff. Yeah, and still plate tectonic issues, the influence of electricity in the rock forming process and the current connection between science, mythology and history of Finland part 2. I made a picture just, I have no idea where I have been before. So let's just continue from here. We are still talking about pebbles and stuff. I have been showing this last time already. That's me. The author, standing in front of a dune, conventional theory considers these kinds of mounds as glacial deposits, so-called moraines, but the author considers them as dunes, i.e., winds were creating these landscape features, winds like no one alive has ever experienced, but many ancient tales are telling us. So, not only do I stay around or sit around and watch clouds, but I also make every now and then some field trips because I really would like to know what's going on. And I really like to explore stuff, find new things, or already known repetitive patterns like craters in lines. And I think they are very intriguing. It's a bit hard for, like, there should be always something in order for size comparison. And this rock is basically on an island in the river. And it's very interesting because you can see basically from where the energy came and what direction the winds were blowing at the moment of creation in time. And there would be so many things just on this one rock for many people to get their minds blown. That's the rock basically, what is visible. And it's rather high, it's rather steep. Like from the side, it's a bit hard to climb up because it's very steep. And also smooth and also rocked, as you have seen. Then we have, these were probably together once, maybe. And they either got separated when they dropped down, or there has been a huge shock wave that just separated them. And you can see the quartz veins aligned perfectly, which are quite likely expressions of shock waves, according to Andrew Hall. And here we have more aligned patterns in the stone. They are very fine. And they can be very big, such as mountain ranges, but they continue as you go down to the microscopic scale, because it's basically the same thing. It's about electromagnetic separation of different elements according to their electromagnetic properties. And so here we are looking at vitrified clay. And clays come in many forms. Some they have very high aluminium content, some of which have very high iron content or high sulfur content or whatever mixes, you know. But if it's clay, it's usually there are microcrystals and aluminium, which makes basically clay, which is an important thing to understand. That aluminium is a very important part of clay, and here it's not well visible, but we have here. I couldn't dig out more, but this is continuing here on the other side. So this has been a very big shock wave that created this, I don't know, 30 centimeter wide gap. Yeah, despite 30 centimeters doesn't seem to be, or maybe will sound big, but we have these kind of features that span for kilometers. And we also have random rocks laying all around the place in different sizes. Some of them are rounded, some are not. As for example this one, almost perfectly 90 degrees, which might be related to tessellation and stuff like that. And here we have an almost perfect square and stuff. Yeah, it's a bit hard to get a glimpse of the picture or of the size of the boulder. And here we are on top of a dune that is made out of sand. If you would dig 20 centimeters into the ground here, you will find sand. Maybe some gravel. And on top of that dune, hill, mound, you can see this longer grass here growing, and the vegetation is different. In other words, here in this area there's water coming out. It's a wet place. On top of the hill there's a well, basically. And if you turn around a few meters, you can see this. And this is just going on forever. That's very massive. Here you can see of what those dunes are made of. Random stones. You can find anything there. And some of them are rather big. But there is like so many different kinds of stones you can find. You can see here the top layer, which is maybe half a meter thick or something, even maybe in some places less. And exploring those sand dunes is very annoying because you have to every now and then paddle through the sand. And I try to take a picture because, I don't know, it doesn't really shine through, but this part of the sand is different in color than this. I don't know if that helps, but this is a handful of sand. No, it's not really visible, but they have different color. And there is water all over the place, like at very shallow depths. There are many, many little ponds and many, many little places where you can find where it's wet, moisture. And there are many of them are far above the closest water body level, so they are elevated. And here is something I wanted to show you. I made a Google Lens translation of that. So The bipolar region was freed from continental ice about 9,500 years ago. Continental ice piled up a layer of sand and gravel tens of meters thick here. The area has been an economic forest since the 17th century, when tar and coal burning began here. A few tar pits remind us of that time. Until the 1940s. The area was a crown forest, hence the name Kruunukangas. There has been no permanent settlement. So, continental ice piled up layers of sand and gravel tens of meters thick here. Yeah, sometimes I feel like adventure, looking for stuff. I, in a way, know what I'm looking for, and it's very interesting to find new things. And I also watch every now and then professionals, geologists talking about their thing, and I just wanted to share with you a small part of a video I recently watched, and in a way it was very strange because he's a professional geologist. I am more of a random dude making his own research and being critical and maintaining a critical thought and stuff and having the eyes to see. But anyway, let's have a quick look into how a professional geologist perceives his environment.
I've wandered this area many times thinking about not only my family heritage, but the profound geologic history written in these rocks. Certainly some interesting formations to hike around in, and I think this is pretty representative of what we are seeing in this area. It's just a mess. It's kind of a strange, clumpy mess. I can't really make heads or tails of it. I look at it, it's very, very rough to the extreme. We've seen more subtle examples of this, but now, boy, this is intense. And when a geologist comes to something like this, if you have a lot of experience, you have some ideas, but let's assume for a minute that I don't. And I come to this and I go, oh my word, I don't know what's going on here. It just.
Wait a second, let's go back to the very beginning when he starts to talk about that rock.
Seems like a mess.
It just seems like a mess. All right. Let me point out just a few things. We have very highly structured material here that has many horizontal lines. And not only this rock he stands in front of, but there is in the background, there is more going on of the same thing. And we have also vertical patterns. I don't know. He's standing very close. He should see all these cracks here and should somehow understand that it's not a mess. It's highly structured. There has been huge forces working on this because, in a way, the more energy or force or whatever you want to call it gets put into something, the higher the order is of what is going to be. It's a bit hard to understand. I have to make once maybe a video about that because it relates to Finland. But anyway, about force and order, the funny analogy that works in many different things. But now let's go back to my own field trips, which aren't full of messes. Despite it might look like that. But this is just the diversity of pebbles you can find And I want to point out that they are all more or less a little bit rounded. They are not too sharp. And this is just one pile. You could dig for days in this one pile and you would find many amazing stones, I tell you. And that's a little bit an overview. As the sun made a small disappearance behind the clouds. And then, that's a zoomed in picture, basically from the other side. And here we can see basically a cut through of the layers and how highly structured that is. I don't know what these are. These are very interesting. I don't know if they are just there and this dropped down from there. Or is this structure going further in the ground like that? There's another one, and they seem to be stronger in structure because they keep the sand. I don't know what they are. I don't know if I can go there. So this is rather heavily zoomed in from a few hundred meters or something. But we can see that we have different colors in the sand layers and different thicknesses of the sand layers. And also that, I don't know if this line is artificial, but we can see a waveform and there is more or other material in that part. And I think that's the same, and here is a little bit on the other side. And this is just continuing, and you can also see that there are layers of rocks, and then there's like smaller stuff, and there is another layer of rocks, and then is the sand. The sand is on top. Yeah, this might be an interesting part to dig into. See what's found in there. And that's a way, an overview. The waves of the dunes. And here they seem to be rather straight and then they go down again. And maybe here we have a Prandtl expansion fan. For those who know what it is. And in other places where they were digging a bit deeper, we can see layers on layers and layers of deposits. And one thing I really would like to point out to everyone watching is about the size of the material. It's not only about the constituency of the material, it's about the size. Because if we are talking about the size, then we have to think about different harmonics in the wind patterns, standing wave harmonics and stuff like that. It seems if there would be different frequencies in the wind waves and stuff like that, they would gather different sized particles. And in this case, the particles, they can be as big as small cars and dust grains, all in between. So the winds, they were carrying everything. And this might be a rather strange picture, but I want to point something out. Here we can see these lines, okay? And I would say, I think, I'm not too sure, I haven't seen these piles getting created, but I assume that these have been truckloads that were deposited here. And if we just imagine the truck being a strong wave of winds, like, you know, a tsunami of wind, which is very heavily filled with all kinds of stuff and things like that. And they are blowing and it gets this shockwave pattern and they just start to pound in a way the same way. And they amp up. If the truck would be the wind, it would leave the pattern. Because the truck is the energy. It needs fuel, it has all the stuff in the motor and all the kinds of things that turn and spin, and it has the torque and all this, like, it's the energy. And in this case, it's made by humans, it is a truck, but if we take nature, it's the wind. And if the wind deposits something somewhere, it will leave a pattern. It's the energy that leaves the patterns. So that's the basic analogy between deposits leaving patterns behind. And it needs energy in order to get a pattern done in the first place. Yeah, but anyway, I think I leave it here. Here's a pattern in the stone, and I made a 3 beside it. I thought it's funny. But anyway, we have to keep an eye on the weather. Should we just still check about the sulfur emissions of the Ohio Valley? Yeah, maybe we have to check still the sulfur dioxide constituency of the air, SO2. Anything going on in the Ohio Valley? Yeah, I just learned recently about the Ohio Valley. If I'm not totally wrong, that's somewhere the Ohio Valley. So there seems to be constantaneously some sulfur emissions. Coming from the Ohio Valley. This might explain some weather patterns, for example, in New York. Now let's see what the SO2 is doing in the region where we have this storm, Debby, I think it was. Maybe you're getting lucky. Because if the storm here, maybe that's here, I don't know. It looks like. If the storm doesn't get mixed up too badly with the SO2, then you could get lucky. But if there's a mixing up, if the storm gets, so to say, fueled with SO2, sulfur dioxide, I think you could get a problem. And here it seems that it starts to pull in SO2 into the storm system next Thursday, which is a prediction. That could be totally wrong. Also, the sulfur emissions of the Ohio Valley could be totally wrong, because how could they predict sulfur emissions? You know. But there seems to be something. There are many places on Earth where we have frequent sulfur emissions. But this Ohio Valley thing is rather interesting, because I think the Ohio River is also a wide river. And I have been talking about wide rivers and writing about wide rivers in my mountain water paper. And you can check out the mountain water playlist if you're interested into it. Yeah. I don't know, maybe that's Popocatépetl here. So we have basically the reason for those sulfur emissions, because it's a very big volcano. But nonetheless, there's just sulfur emissions all the time from the Ohio Valley. And the huge cloud hanging over Washington, D.C., New York, and stuff like that. Yeah, I haven't noticed this earlier. I recently learned about some copper mines near Lake Michigan. And that was very interesting, because if there's copper mines, stuff like that, or bronze in the vicinity, that would explain to some degree the sulfur currents, but this doesn't explain the sulfur dioxide emissions. So there must be something else. Is there a strong telluric current flowing through that valley? There might be a lot of clay there, because New York, I think it's all built on clay, which is not a good thing. But that's not my problem. So anyway, I think I leave it here. Somewhere we started with plasma tubes, we watched some rocks, and now we are watching at the Ohio Valley sulfur emissions. Yeah. Thanks. Bye.